So guys, in today's video we are going to deal with physical properties of the carboxylic acids and chemical properties of your carboxylic acids. So to begin our video, let us deal with first physical properties of carboxylic acid. So far till now in organic chemistry, whenever we were dealing with the physical properties, our main intention was to say or what to notice what would be its boiling point and what would be its solubility. So these are the two factors so far we have learned in the organic chemistry. So here also we are going to judge the carboxylic acids with respect to these two factors. So first of all, let us deal with its boiling point. Remember guys, when I am dealing with the boiling point, I am saying that your carboxylic acids are having the highest boiling point. Of course, I have given you a statement. What I am saying, so when we are considering the physical properties under that one factor, the boiling point, I am saying you that your carboxylic acids are having the higher boiling point. Yes. Now the question arises within us. Why is it so, sir? Why carboxylic acids are having the higher boiling point? If that question, if I'm going to ask you, what would be your answer? Yeah, recall. What would be your answer? Whenever we are dealing with the boiling point, you should get remembered in your brain, okay, boiling point, there should be some sort of relationship with respect to the hydrogen bonding. Alva. Then you have to make sure that your mind should switch. Okay, now the boiling point is increasing. That means what should happen with respect to the hydrogen bonding? Of course, there should be an increased hydrogen bonding interaction. Alva? Hydrogen bonding ಜಾಸ್ತಿ ಆದಷ್ಟು ಏನಾಗುತ್ತೆ, ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಹೈಡ್ರೋಜನ್ ಬಾಂಡಿಂಗ್ ಕಮ್ಮಿ ಆದಷ್ಟು ಏನಾಗುತ್ತೆ, ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಕಡಿಮೆ ಆಗುತ್ತೆ. ಆದ್ರೆ ಹೈಡ್ರೋಜನ್ ಬಾಂಡಿಂಗ್ ಅಂತ ಬಂದ್ಕೊಳ್ಳೆ ನಮ್ಗೆ ಅಲ್ಲಿ ಇರೋದು ಎರಡು ತರದ ಹೈಡ್ರೋಜನ್ ಬಾಂಡಿಂಗ್. ಏನದು? ಒಂದು ಇಂಟ್ರಾ ಮಾಲಿಕ್ಯುಲರ್ ಹೈಡ್ರೋಜನ್ ಬಾಂಡಿಂಗ್. ಹಾಗಾದ್ರೆ ಅರ್ಥ ಏನು? ವಿತಿನ್ ಅ ಮಾಲಿಕ್ಯೂಲ್ ಹೈಡ್ರೋಜನ್ ಬಾಂಡಿಂಗ್ ಇದ್ರೆ ಅದು ನಾವೇನಂತ ಹೇಳ್ತೀವಿ, ಇಂಟ್ರಾ ಮಾಲಿಕ್ಯುಲರ್. ಅದೇ ಎಲ್ಲಾದ್ರೂ ಒಂದು ಮಾಲಿಕ್ಯೂಲ್ ಜೊತೆ ಅದೇ ರೀತಿದು ಇನ್ನೊಂದು ಮಾಲಿಕ್ಯೂಲ್ ಜಾಯಿನ್ ಆಗಿರೋದು ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಹೈಡ್ರೋಜನ್ ಬಾಂಡಿಂಗ್, ಅದಕ್ಕೆ ನಾವೇನಂತೀವಿ, ಇಂಟರ್ ಮಾಲಿಕ್ಯುಲರ್ ಹೈಡ್ರೋಜನ್ ಬಾಂಡಿಂಗ್. So when it come under the concept of over here carboxylic acid, do remember your carboxylic acids are having the higher boiling point. The main reason is because of your intermolecular hydrogen bonding. What we are saying, intermolecular hydrogen bonding. ಹೇಗಿರುತ್ತೆ ಸರ್ intermolecular ಅಂದ್ರೆ? As I have said earlier, one molecule will be interacting with another molecule. That means they will be same itself. Okay, ಇದು ಆಸಿಡ್, ಕಾರ್ಬಾಕ್ಸಿಲಿಕ್ ಆಸಿಡ್, ಅದು ಕಾರ್ಬಾಕ್ಸಿಲಿಕ್ ಆಸಿಡ್. ಆದ್ರೆ ಏನಾಗ್ತಾ ಉಂಟು, ಇದೇ ಸೆಪರೇಟ್, ಅದೇ ಸೆಪರೇಟ್. ಬಟ್ ಅವೆರಡು ಮಧ್ಯೆ ಇಂಟ್ರಾಕ್ಷನ್ ಏನುಂಟಲ್ಲ, ಅವೆರಡು ಹೇಗೆ ಜಾಯಿನ್ ಆಗಿದೆ ಅಂದ್ರೆ, ಇಟ್ ಇಸ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಯೋರ್ ಹೈಡ್ರೋಜನ್ ಬಾಂಡಿಂಗ್. Since the hydrogen bonding is existing between the two molecules, different molecules, so ಅವಾಗ ಏನಾಗುತ್ತೆ, ಆ ಒಂದು ಟೈಪ್ ಆಫ್ ಹೈಡ್ರೋಜನ್ ಬಾಂಡಿಂಗ್ ನಾವು ಏನಂತ ಹೇಳ್ತೀವಿ, ಇಂಟರ್ ಮಾಲಿಕ್ಯುಲರ್ ಹೈಡ್ರೋಜನ್ ಬಾಂಡಿಂಗ್. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಕನ್ಫ್ಯೂಷನ್ ಉಂಟಾ? ಒಂದು ಎಕ್ಸಾಂಪಲ್ ನೋಡೋಣ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಹಿಯರ್ ಐ ವಿಲ್ ಬಿ ಟೇಕಿಂಗ್ ಮೈ ಎಥೆನೋಯಿಕ್ ಆಸಿಡ್ CH3C ಡಬಲ್ ಬಾಂಡ್ OH, ಈ ತರ ಬರ್ಕೊಳ್ಳೋಣ. ಓಕೆನಾ? ಫಾರ್ ಟೈಮ್ ಬಿಂಗ್. Similarly, here also I am going to write COH, and here I am going to take as a CH3, and here I am taking as O. Of course, now when you are noticing this, don't consider your hydrogen bonding over. Just consider this. This is also ethanoic acid. This is also ethanoic acid. But what is this? This is one molecule. This is another molecule. Alva? So now what is happening? Of course, we know that there will be some sort of electronegativity difference between this carbon and oxygen, between this oxygen and hydrogen. So what happens? Here we can see such dotted lines. Alva? Here we could see such dotted lines. So this dotted lines, whenever you have been seeing these dotted lines, do remember your hydrogen bonding is represented by your dotted lines. Okay, ಇದರ ಒಂದು ಸ್ಲಾಶ್ ಇದರ ಕಟ್ ಲೈನ್ಸ್ ಇದ್ರೆ ಅದೇನಂತ ಅರ್ಥ, ದಟ್ ರಿಪ್ರೆಸೆಂಟ್ಸ್ ಯೋರ್ ಹೈಡ್ರೋಜನ್ ಬಾಂಡಿಂಗ್. ಓಕೆ, ಸೊ ಒಂದು ಮಾಲಿಕ್ಯೂಲು ಇನ್ನೊಂದು ಮಾಲಿಕ್ಯೂಲ್ ಜೊತೆ ಸಪರೇಟ್ ಆಗಿ ಇಂಟರಾಕ್ಟ್ ಆಗ್ತಾ ಉಂಟು ಥ್ರೂ ಯೋರ್ ಹೈಡ್ರೋಜನ್ ಬಾಂಡಿಂಗ್ ಅಂತ ಏನಾಗಿರುತ್ತೆ ಯೋರ್ ಇಂಟರ್ ಮಾಲಿಕ್ಯುಲರ್ ಹೈಡ್ರೋಜನ್ ಬಾಂಡಿಂಗ್. ಇಸ್ ದ್ಯಾಟ್ ಕ್ಲಿಯರ್? ವಿತಿನ್ ಅ ಮಾಲಿಕ್ಯೂಲ್ ಇದ್ರೆ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇಫ್ ಐ ಸೇ ಲೈಕ್ ದಿಸ್, here you are having as what I can say, here let us take as a C double bond O and a OH, and here you are having as an OH. So here like this interaction is there. For example, if we consider, that is what is happening within a molecule itself, you are having an hydrogen bonding interaction. So this will be called as what? Intramolecular. This will be called as what? Intramolecular. Within a molecular hydrogen bonding it is intramolecular. Two different molecules jothe nimma interaction idre adu navu enanta heltivi intermolecular. And when you are coming to the aspect of the boiling point of the carboxylic acid, do remember, of course your carboxylic acids are having the higher boiling point. The only reason is because of your intermolecular hydrogen bonding. Is that clear? No doubt. Can we move further then? Okay. Now let us deal with another factor which is called as your solubility. That is, in case if I am going to add your carboxylic acid to your water, whether it would be soluble or whether it would be insoluble, that we have to see. Do remember guys, your carboxylic acids, to be more particular, we can say your lower membered carboxylic acids. Lower membered carboxylic acids are soluble in water. They are soluble in water. Why sir you have mentioned lower membered? Because when I am considering the high membered carboxylic acids, high membered carboxylic acids, what I am observing is they are insoluble in water. They are insoluble in water. Now the question arises within us. Why sir? When you are considering your lower membered, they are soluble in water. But when you are considering the higher membered, why they are insoluble in water? Big question mark arises a lot. So when you are asking me this question, I would just like you to recall the concept of your surface chemistry. And more particularly, your cleansing action of soap. Are you getting the picture? How does your mycenae was formed? Where was your tail? Where was the head? Alva? What was that tail part? It was away from the water. And what it was containing? Hydrocarbons. So adyak heltidini andre, do remember guys, as the membered, that is as you are getting higher and higher membered hydrocarbons, what happens? They will be acting as a hydrophobic. They will be acting as what? Hydrophobic. Eno hydro andre water, phobic andre repelling, not loving anta. So they are not loving water. So enagutte, when you are considering this higher membered hydrocarbons which is attached to the carboxylic acids, of course your carboxylic acids alli charge separation untu, adu polar should interact with the polar. Adre adur jothe enagide higher membered hydrocarbons untu. So idun consider ಮಾಡಿದಾಗ, carboxylic acid consider ಮಾಡಿದಾಗ higher membered hydrocarbons ಏನಾಗುತ್ತೆ, ಡಾಮಿನೆಂಟ್ ಆಗಿಬಿಡುತ್ತೆ. ಸೊ ಡಾಮಿನೆಂಟ್ ಆಗಿದ್ದ ಕಾರಣದಿಂದ ಏನ್ ಮಾಡುತ್ತೆ, ಇದು ಓವರ್ ಆಲ್ ಆಗಿ ಆ ಮಾಲಿಕ್ಯೂಲ್ ಹೈಡ್ರೋಫೋಬಿಕ್ ಹಂಗೆ ಆಕ್ಟ್ ಮಾಡುತ್ತೆ. ಸೊ ಒನ್ಸ್ ಇಟ್ ಆಕ್ಟ್ಸ್ ಆಸ್ ಅನ್ ಹೈಡ್ರೋಫೋಬಿಕ್, ದಟ್ ಇಸ್ ವಾಟರ್ ರಿಪೆಲಿಂಗ್, ವಾಟ್ ಹ್ಯಾಪನ್ಸ್, ಇಟ್ ಬಿಕಮ್ಸ್ ಇನ್ಸಾಲ್ಯುಬಲ್ ಇನ್ ವಾಟರ್. It becomes insoluble in water. But when considering with respect to the low membered ಏನಾಗುತ್ತೆ, of course carboxylic acid ಉಂಟು ಆ ಗ್ರೂಪ್, ಅದ್ರಲ್ಲಿ ಕೂಡ ಚಾರ್ಜ್ ಸೆಪರೇಷನ್ ಉಂಟು. ಸೊ there charge separation will be acting as what? Dominant when compared to that of your hydrocarbon chain. So ಅವಾಗ ಓವರ್ ಆಲ್ ಏನಾಗ್ಬಿಡುತ್ತೆ, low membered carboxylic acid, they will be acting as a hydrophilic, water loving. So they will be getting easily soluble in water. So what I am going to just make you sure that whenever you're talking about the boiling point and you have been asked with a reason, why does your organic compounds, or more particularly why does your carboxylic acids are soluble in water, you should get your brain, okay, the only reason for your carboxylic acid to be soluble in water is because they can form hydrogen bonds with water. ಓಕೆ, ಯಾವುದೇ ಒಂದು ಆರ್ಗ್ಯಾನಿಕ್ ಕಾಂಪೌಂಡ್ ನೀವು ತಗೊಂಡು ಅದು ವಾಟರ್ ಅಲ್ಲಿ ಸಾಲ್ಯುಬಲ್ ಆಗ್ತಂದ್ರೆ ಅರ್ಥ ಏನು, ಇಟ್ ಕ್ಯಾನ್ ಫಾರ್ಮ್ ಎನ್ ಹೈಡ್ರೋಜನ್ ಬಾಂಡ್ ವಿತ್ ವಾಟರ್. ಹೈಡ್ರೋಜನ್ ಬಾಂಡ್ ವಿತ್ ವಾಟರ್. This is a general case for all the organic compounds. But when the question arises, why a lower membered carboxylic acids are soluble, but why not your higher membered? Because in a higher membered, the hydrocarbon chain will be acting as a hydrophobic, water repelling. So that is the reason they are insoluble. Whereas in the lower member, what happens? They will be acting as a hydrophilic. So they will be soluble in water. Coming with respect to the boiling point, why does the organic compounds are having the higher boiling point? The only reason is because of their two types of a hydrogen bonding interaction. It could be your intermolecular or else your intramolecular. So whenever such a hydrogen bonding interaction is there, it should come to your brain, okay, this can have some sort of a difference in yes, boiling point. It can have a higher boiling point. Okay. So these are the two important aspects one has to know when we are dealing with the physical properties of your carboxylic acids. Is that clear? I hope there is no doubt. Let us deal with now the second concept, which is called as chemical properties of carboxylic acids. Chemical properties of carboxylic acids. So guys, now when we are considering the chemical properties of the carboxylic acid, do remember, here we are going to study the reactions which will be involving your C and an OH bond. What does it mean, sir? Now, if you ask me to write just the functional group of your carboxylic acid, how can I write it? Of course, C double bond O and an OH. Alva. 1, 2, 3, 4. So now what did I say is, when we are talking about the chemical properties of the carboxylic acid, whatever the reactions we are going to study from now onwards, which will be involving only the bond which will be existing between this C and this OH bond. Okay. Overall, the reactions will be undergoing the concept of this much. Okay. So these are the reactions which we are going to study. The first important reaction under the chemical properties we are going to study is called as reaction with phosphorus pentachloride, phosphorus trichloride, and that of your thionyl chloride. Do remember guys, whenever your carboxylic acids are reacting with this phosphorus halides and the sulfur halides, the reactions are similar when you are observing with respect to your alcohols. I repeat, the reactions are similar with respect to your alcohols. Turn the pages in your brain now. Hegittu, what happens whenever your alcohols were treated with this phosphorus halides? Of course, we were getting what? RCOCl. That means an acyl chloride. Here also the same reactions are followed. That is RC double bond OH. Whenever it is reacting with your phosphorus pentachloride, you are going to get as an RCOCl plus POCl3 plus HCl. When the same carboxylic acid is getting treated with phosphorus trichloride, you are going to get RCOCl. That is common in everything, but the side products or the byproducts are different. Here you are going to get as orthophosphoric acid. And the same carboxylic acid, when it is treated with your thionyl chloride, SOCl2, what you are going to get? RCOCl plus SO2 plus HCl. And here we write it as in the gaseous medium. Now you just recall, because I am going to ask you a question. I have given you a carboxylic acid and I have asked you to prepare an acyl chloride. And of course, I have given all the three reagents along with your carboxylic acid. That is phosphorus pentachloride, phosphorus trichloride, and thionyl chloride. Okay, only this thing. I am going to repeat my question. I have given you a carboxylic acid. For example, you just consider I have given you some, which one? Ethanoic acid. Okay, and I have asked you to prepare the corresponding acyl chloride. And I have given the another three important reagents. That is your phosphorus pentachloride, phosphorus trichloride, and thionyl chloride. Now my question is to you. Among these three, you have to just choose one. What I am saying, among these three, you have to choose only one, and I have to get the product in a maximum amount. I have to get the product in the maximum amount. So which of these three reagents you are going to use? ಈ ಮೂರಲ್ಲಿ ಯಾವ ರಿಯೇಜೆಂಟ್ ನ ಯೂಸ್ ಮಾಡಿ ನೀವು ಅಸೈಲ್ ಕ್ಲೋರೈಡ್ ನ ಮ್ಯಾಕ್ಸಿಮಮ್ ಅಮೌಂಟ್ ಅಲ್ಲಿ ತಗೋಬಹುದು? Yes, if you are saying it is thionyl chloride, very good. What is the reason, guys? What is the reason? Here you could just observe that when we are getting the main product as the acyl chloride, along with the byproducts, we are going to get a sulfur dioxide and a HCl. But what is their medium? Of course, they are in the gaseous phase. So as soon as they will be formed, they will be getting evaporated. Alva, evaporate agutte. So a beaker alli enu ulkobeku? Bari namma acyl chloride. So that is the reason, in case if you have been asked to prepare an acyl chloride with carboxylic acid, we majorly choose the thionyl chloride. The only reason is because whatever the byproducts we are going to get in this case will be in the gaseous medium, which could be easily removed out. But when you are considering with respect to the PCl5, do remember, in this reaction we use a pyridine. Of course, many times I have said you why we are using the pyridine. In alcohols kuda the same concept was arised. Yes, because here whatever the acid which has been formed as a HCl, it is acidic in nature. So in order to neutralize it, we need a base. So that base will be acting as that of your pyridine, which is going to interact with your HCl and decreases its acidic strength. Is that clear? So what we came to know, whenever your carboxylic acids are reacting with your phosphorus halides or sulfur halides, the reaction will be similar with respect to as we have observed in your alcohols. The RCOOH will be behaving similar to that of your alcohols and the same products you are going to get. So when the concept is arising that which is the most suitable method for the preparation of acyl chloride, it is your thionyl chloride. The only reason is because the byproduct whatever you are going to get will be in the gaseous phase. Is that clear? So this was one of the most important reactions so far we have studied under the concept of chemical properties of carboxylic acid. The next reaction we are going to study is called as reaction with ammonia. Reaction with ammonia. Ammonia ಯಾವ ತರ ಬರಿಬಹುದು ನಾವು? NH3 ಅಲ್ವಾ? Remember guys, whenever you are treating your carboxylic acid with ammonia, you just say me, I don't want the product. ನಂಗೆ ಇಲ್ಲಿ product ಬೇಡ. I just want the name of the product, general name. That is whether you what type of a product you are going to get over here. ಅರ್ಥ ಆಗ್ತಾ ಉಂಟಾ? Whether it would be a neutralization reaction, whether it would be a double decomposition reaction, whether it would be an what you can say redox reaction. What type of a reaction would you like to observe over here? Reactants are on your side, okay, because it is a general thing. ನಮಗೆ ಇಲ್ಲಿ ಮೇನ್ ಪ್ರಾಡಕ್ಟ್ ನಂಗೆ ಬೇಡ, ಯಾಕಂದ್ರೆ ಬಿಕಾಸ್ ಐ ಹ್ಯಾವ್ ನಾಟ್ ಡೀಲ್ಡ್ ವಿತ್ ಇಟ್, ಸೊ ಐ ಆಮ್ ನಾಟ್ ಆಸ್ಕಿಂಗ್ ಯು ದಿ ಪ್ರಾಡಕ್ಟ್ ನೇಮ್, ಐ ಆಮ್ ಜಸ್ಟ್ ಆಸ್ಕಿಂಗ್ ದಿ category of the product which it will be falling under. Yes, closely observe what are the reactants we have chosen. One is an acid, another is a base. I repeat, one is an acid, another is a base. So we know that whenever an acid is reacting with a base, of course we are going to get a salt. Alva? Of course we are going to get a salt. Simply, if I am going to say HCl plus NaOH gives you NaCl. NaCl ಅಂದ್ರೆ ಅರ್ಥ ಏನು? Na plus Cl minus. That means ಯಾವತ್ತೇ ಒಂದು ಸಾಲ್ಟ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ಅದು ಒಂದು ಕ್ಯಾಟಯನ್ ಇರುತ್ತೆ, ಒಂದು ಆನಯನ್ ಇರುತ್ತೆ. ಇದು ನಮ್ಗೆ ಗೊತ್ತಲ್ವಾ? ಬಿಕಾಸ್ ವೆನೆವರ್ ಯು ಆರ್ ಡೂಯಿಂಗ್ ಎ ಫಸ್ಟ್ PUC ಸಾಲ್ಟ್ ಅನಾಲಿಸಿಸ್, ಏನ್ ಹೇಳ್ತೀವಿ ನಾವು ನಿಮಗೆ ಫೈಂಡ್ ಔಟ್ ಮಾಡಕ್ಕೆ? ಒಂದು ಬೇಸಿಕ್ ರಾಡಿಕಲ್, ಇನ್ನೊಂದು ಆಸಿಡ್ ರಾಡಿಕಲ್. ಇನ್ ಸಿಂಪಲ್ ವರ್ಡ್ಸ್, ಅ ಕ್ಯಾಟಯಾನ್ ಅಂಡ್ ಅನ್ anion. Because whenever we talk about a salt, of course it should have one cation and one anion. Similarly over here also, when you are treating a carboxylic acid with an ammonia, of course here one is an acid, another is a base, so it should form a salt over here. Yavadu salt nodi, for example, if I take here R as your CH3, acetic acid na consider madana. So what you will be getting? CH3 COO minus, yes, and NH4 plus. ಅರ್ಥ ಆಗ್ತಾ ಉಂಟಾ ಏನಾಗಿದೆ ಇಲ್ಲಿ? ಈ ನೈಟ್ರೋಜನ್ ಆಟಮ್ ಮೇಲೆ ಏನ್ ಲೋನ್ ಪೇರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇತ್ತಲ್ಲ ಅದು ಯಾವ್ದು ಜೊತೆ ಇಂಟರಾಕ್ಟ್ ಆಗ್ತಾ ಉಂಟು, ಈ ಹೈಡ್ರೋಜನ್ ಜೊತೆ ಇಂಟರಾಕ್ಟ್ ಆಗ್ತಾ ಉಂಟು. ಇಲ್ಲಿ ಏನ್ ಬಾಂಡ್ ಇತ್ತಲ್ಲ OH ಮಧ್ಯೆ, ಈ ಬಾಂಡ್ ಏನ್ ಮಾಡ್ತು, ಆಕ್ಸಿಜನ್ ತನ್ನ ಕಡೆಗೆ ಎಳ್ಕೊಂತು. ಅವಾಗ ಏನಾಯ್ತು, CH3COO ಮೈನಸ್ ಆಯ್ತಾ, H+ ಏನ್ ಹೊರಗೆ ಬರ್ತಾ ಉಂಟು ಅದೇನ್ ಮಾಡುತ್ತೆ, ಲೋನ್ ಪೇರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ನೈಟ್ರೋಜನ್ ಆಟಮ್ ಜೊತೆ ಇಂಟರಾಕ್ಟ್ ಆಗಿ ಏನಾಗುತ್ತೆ, NH4+ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ಸೊ ಓವರ್ ಆಲ್ ಈಗ ಏನಾಯ್ತು, ಒಂದು ಕ್ಯಾಟಯಾನ್ ಒಂದು ಆನಯಾನ್ ಅವೆರಡು ಕಂಬೈನ್ ಆಗುತ್ತೆ. So when such two cations are combining by the reaction of an acid and a base, it would be a salt. So what type of a salt it is? Ammonium salt ಅಂತ ಹೇಳ್ಬೋದಾ ಜನರಲ್ ಆಗಿ. ಈಗ ಇಲ್ಲಿ CH3 ಇರಲಿಲ್ಲಪ್ಪ, R ಅಂತ ಇತ್ತು ಅಂದ್ರೆ ಅರ್ಥ ಏನು, it will be an ammonium salt. But since R is having a CH3 group, what I can call it as ammonium acetate ಅಲ್ವಾ, ammonium acetate. ಇದು ಅಮೋನಿಯಂ ಅಲ್ವಾ, ಇದಿಷ್ಟು ಎಸ್ಟರ್ ಅಲ್ವಾ, COO ಗ್ರೂಪ್ ಉಂಟಲ್ವಾ, ಎಸ್ಟರ್ ನಾವು ಕಲ್ತು ಅಲ್ವಾ, ಆಲ್ಕೋಹಾಲ್ಸ್ ಫಿನಾಲ್ಸ್ ಅಂಡ್ ಎಸ್ಟರ್ಸ್ ಅಲ್ಲಿ. ಸೊ ಆಲ್ಕೋಹಾಲ್ ಫಿನಾಲ್ಸ್ ಈಥರ್ಸ್ ಕಲ್ತಿರೋದು, ಸಾರಿ ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಅನ್ ಎಸ್ಟರ್ಸ್ ಅಂತ. ಓಕೆ, ಎಸ್ಟರ್ಸ್ ಅಂತ ಬಂದಾಗ O8 ಅಂತ ಬರುತ್ತೆ. ಐ ವಿಲ್ ಡೀಲ್ ವಿತ್ ಬಿಫೋರ್ ದ ಕ್ಲಾಸಸ್, ಬಟ್ ಯು ಜಸ್ಟ್ ಫಾರ್ ಅ ವೈಲ್ ರಿಮೆಂಬರ್ ದಟ್ ಇಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ವಾಟ್, ಅಮೋನಿಯಂ ಅಸಿಟೇಟ್. ಓಕೆ, ಏನ್ ಸಾಲ್ಟ್ ಫಾರ್ಮ್ ಆಗಿದ್ದಾರೆ, ಇಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ವಾಟ್, ಅಮೋನಿಯಂ ಅಸಿಟೇಟ್. ದ ರಿಯಾಕ್ಷನ್ ಡಸಂಟ್ ಸ್ಟಾಪ್ಸ್ ಓವರ್ ಹಿಯರ್. ವಾಟ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಡೂ, ವಿ ವಿಲ್ ಬಿ ಫರ್ದರ್ ಹೀಟಿಂಗ್ ಇಟ್. ಏನ್ ಮಾಡ್ತೀವಿ, ವಿ ವಿಲ್ ಬಿ ಫರ್ದರ್ ಹೀಟಿಂಗ್ ಇಟ್. ನಮ್ಗೆ ಗೊತ್ತಲ್ವಾ, ಯಾವತ್ತೇ ಒಂದು ನ್ಯೂಟ್ರಲೈಸೇಷನ್ ರಿಯಾಕ್ಷನ್ ಆಗ್ಬೇಕಂದ್ರೆ ಅರ್ಥ ಏನು, ಒಂದು ಸೈಡ್ ಪ್ರಾಡಕ್ಟ್ ನಮ್ಗೆ ಏನ್ ಬರ್ತಾ ಇತ್ತು, ವಾಟರ್ ಬಂದೇ ಬರುತ್ತಲ್ವಾ. ಸೊ ಆ ರೀಸನ್ ಇಂದ ಇದನ್ನ ವಾಟರ್ ನ ಹೊರ ತೆಗಿತೀವಿ. ಸೊ ವಾಟರ್ ನ ಹೊರ ತೆಗೆದಾಗ ಬರೋ ಪ್ರಾಡಕ್ಟ್ ನಮ್ಗೆ ಇಂಪಾರ್ಟೆಂಟ್, ವಿಚ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಆನ್ ಅಮೈಡ್ಸ್. ಜನರಲ್ ಆಗಿ ನಾವು ಹೇಳೋದು ಅಮೈಡ್ಸ್, ಬಟ್ ಇಲ್ಲಿ ಈ ಕೇಸಲ್ಲಿ ನಾವು ಇದನ್ನ ಏನಂತ ಹೇಳ್ತೀವಿ, ಅಸಿಟ್ ಅಮೈಡ್, CH3CONH2 ಅಲ್ವಾ. ಇಲ್ಲಿಂದ ಏನಾಗ್ತಾ ಉಂಟು, ಇಲ್ಲಿಂದ 2 H ಹೊರಗೆ ಹೋಗ್ತಾ ಉಂಟು, ಇಲ್ಲಿಂದ 1 O ಹೊರಗೆ ಹೋಗ್ತಾ ಉಂಟು. ಅವಾಗ ಏನ್ ಉಳ್ಕೊಳುತ್ತೆ, CH3CO, ಈ O ಹೊರಗೆ ಹೋಗಿದೆ, ಇಲ್ಲೂ ಕೂಡ 2 H ಹೊರಗೆ ಹೋಗಿದೆ. ಸೊ ಅವಾಗ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, 2 H ಉಳ್ಕೊಳುತ್ತೆ. ಸೊ CH3CONH2. So generally it will be called as an amide. Whenever you are having the functional group as CONH2, remember, recall, CONH2, it will be called as what, amide. Okay. In this case, since that R we are having a CH3 group, it will be called as what, acid amide, AMIDE. So now what we can say generally, so whenever you are treating your carboxylic acids with an ammonia, it first gives you an ammonium salt. What does it gives you? Ammonium salt, which on further heating at a high temperature, yes, gives you amide. What it does, it gives you amide. So now, will you help me in the next reaction? Okay, thank you very much. Now let me take over here a benzene which has been attached with a carboxylic group. I am going to treat this fellow with ammonia. So ಏನು ಆಗುತ್ತೆ, yes, acido base. ಯಾವತ್ತೆ ರಿಮೆಂಬರ್, ಯಾವುದೇ ಒಂದು ರಿಯಾಕ್ಷನ್ ನಾವು ಮಾಡಿದ್ರು ಆರ್ಗ್ಯಾನಿಕ್ ಕೆಮಿಸ್ಟ್ರಿಲಿ, ಅದಕ್ಕೆಲ್ಲಾದ್ರೂ ಒಂದು ಸ್ಮಾಲ್ ಹಿಂಟ್ ಆದ್ರೂ ಸಿಗುತ್ತೆ ಒಂದು ರಿಯಾಕ್ಟೆಂಟ್ ಏನಂತ, ಓಕೆ ಅಲ್ಲಿ ಅಸಿಡಿಕ್ ಪ್ರೋಟಾನ್ ಉಂಟು, ನಾನು ಹೋಗ್ಬೋದು ಅಂದ್ರೆ ಫಸ್ಟ್ ಯಾವ ರಿಯಾಕ್ಷನ್ ಆಗುತ್ತೋ ಬಿಡುತ್ತೋ, ಸೆಕೆಂಡ್ರಿ ಅದು ಆಸಿಡ್ ಬೇಸ್ ರಿಯಾಕ್ಷನ್ ಆಗೇ ಆಗುತ್ತೆ. ಇನ್ ಕೇಸ್ ಇಫ್ ಇಟ್ ಇಸ್ ಹ್ಯಾವಿಂಗ್ ಅನ್ ಅಸಿಡಿಕ್ ಪ್ರೋಟಾನ್, ಅದನ್ನ ನೀವು ತಲೆಯಲ್ಲಿ ಇಟ್ಕೋಬೇಕು. ಹೈಯರ್ ಕ್ಲಾಸಸ್ ಹೋದಾಗ ತುಂಬಾನೇ ಇಂಪಾರ್ಟೆಂಟ್. ಯಾವ ರಿಯಾಕ್ಷನ್ ಆಗುತ್ತೋ ಬಿಡುತ್ತೋ ಸೆಕೆಂಡ್ರಿ, ಎಲ್ಲಾದ್ರೂ ಅದ್ರಲ್ಲಿ ಒಂದು ಆಸಿಡ್ ಬೇಸ್ ರಿಯಾಕ್ಷನ್ ಆಗ ಎಲ್ಲೇ ಒಂದು ಸ್ಮಾಲ್ ಹಿಂಟ್ ಇದ್ರು ನೀವು ಆ ಹಿಂಟ್ ನ ಬಿಟ್ಕೊಡ್ಬಾರ್ದು, ಅದು ಆಗೇ ಆಗುತ್ತೆ. ಓಕೆನಾ, ಅದೇ ರೀತಿ ಇಲ್ಲಿಗೆ ಏನಾಗ್ತಾ ಉಂಟು, ಇಲ್ಲಿ ಆಸಿಡಿಕ್ ಪ್ರೋಟಾನ್ ಉಂಟಾ, ಇದು ಕೂಡ ಬೇಸಾ, ಸೊ ಏನಾಗುತ್ತೆ, ಆಸಿಡ್ ಬೇಸ್ ರಿಯಾಕ್ಷನ್ ಆಗ್ಲೇಬೇಕು. ಸೊ ಫಸ್ಟ್ ಇಲ್ಲಿ ಏನ್ ಸಿಗುತ್ತೆ ನಿಮ್ಗೆ, ಅಮೋನಿಯಂ ಸಾಲ್ಟ್ ಸಿಗುತ್ತೆ. ಯಾವ ತರ ಬರೀತೀರಾ, CH5COO ಮೈನಸ್ NH4+ ಅಲ್ವಾ. ಇಲ್ಲಿ ನಮ್ಗೆ CH3 ಇತ್ತು, ಅದು ನಾನು ಏನಂತ ಹೇಳಿದೆ, ಅಮೋನಿಯಂ ಅಸಿಟೇಟ್ ಅಂದೆ. ಇಲ್ಲಿಗೆ ಏನೊಂದು ಬೆನ್ಝೀನ್ ಜೊತೆ COO ಗ್ರೂಪ್ ಉಂಟು. ಸೊ ಇದನ್ನ ಏನಂತ ಹೇಳ್ಬೋದು ನಾನು, ಅಮೋನಿಯಂ benzoate, ammonium benzoate. So this is an ammonium salt we have formed. But the reaction doesn't stop over here. On further heating at a high temperature, water molecules will be extracted out. So the final product we are going to get an amide. ಯಾವ ತರ ಇರುತ್ತೆ, CONH2 group benzene ಗೆ attached ಆಗಿರುತ್ತೆ. So what will be the name of this compound? It will be called as benzamide. What it is called as? Benzamide. Do remember, very much important reactions. How can you convert or how can you obtain benzamide from benzoic acid? They can give you in this way directly. Or they can give you, giving this reaction a question mark A and B. So you have to make sure that you are knowing the concept over here. Okay, acid na base jothe treat ಮಾಡ್ತಿದ್ದಾರೆ, salt ಬರಬೇಕು. Salt ನ ಇನ್ನೂ ಸ್ವಲ್ಪ ಹೀಟ್ ಮಾಡಿದಾಗ ವಾಟರ್ ಹೊರಗೆ ಹೋಗುತ್ತೆ. ವಾಟರ್ ಹೊರಗೆ ಹೋದಾಗ ಏನಾಗುತ್ತೆ, ಫೈನಲ್ ಪ್ರಾಡಕ್ಟ್ ನಮಗೆ ಅಮೈಡ್ಸ್ ಬರಬೇಕು. ಅಮೈಡ್ಸ್ ಅಂದ್ರೆ ಅರ್ಥ ಏನು? ವಿಚ್ ವಿಲ್ a compound, an organic compound which will be having the functional group as CONH2. CONH2. Is that clear? Very much important. Okay. Now I am going to give you one important reactions using the previous reaction. Okay. Let us consider our benzene is having a 2 carboxylic group attached. Our benzene ring is attached with 2 carboxylic group, and I am going to use my 2 moles of ammonia over here. Okay. So first, can you help me what you are going to get? Yes, first you are going to get an ammonium salt. Since we are using 2 moles, of course, illu kuda 2 moles of hydrogen protons untu interact agutte. So COO minus NH4 plus COO minus NH4 plus. ಬರಿಬೋದಲ್ವಾ? ಓಕೆ, ಬರ್ದೆ. ಈಗ ಏನ್ ಮಾಡ್ತೀನಿ, ಇನ್ನು ಸ್ವಲ್ಪ ಹೀಟ್ ಮಾಡ್ತೀನಿ, ವಾಟರ್ ಹೊರಗೋಗುತ್ತೆ. ಅವಾಗ ಏನಾಗುತ್ತೆ, ಇಲ್ಲಿ ನಿಮ್ಗೆ ಅಮೈಡ್ ಫಾರ್ಮೇಶನ್ ಆಗುತ್ತೆ ಅಲ್ವಾ? ಇಲ್ಲಿ ನಿಮ್ಗೆ ಏನಾಗುತ್ತೆ, CONH2 CONH2. So this is called as what? Ammonium phthalate. Ammonium phthalate. PHTHALATE. And this is called as phthalamide. What it is called as? Phthalamide. Okay. But do remember, ಈ ಒಂದು ಥ್ಯಾಲಮೈಡ್ ಇಂದ ನಮ್ಗೆ ಇನ್ನೊಂದೊಂದು ಇಂಪಾರ್ಟೆಂಟ್ ಪ್ರಾಡಕ್ಟ್ ಸಿಗುತ್ತೆ. ಏನಿಲ್ಲ, ಇಲ್ಲಿ ಏನ್ ನೀವು ವಾಟರ್ಗೆ ಅಂತ ಹೀಟ್ ಮಾಡಿದ್ರೆ ಇನ್ನೂ ಸ್ವಲ್ಪ ಹೀಟ್ ಮಾಡಿ. ಇನ್ನೂ ಸ್ವಲ್ಪ ಹೀಟ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, ಈ CONH2 ಏನುಂಟಲ್ಲ, ಅದರಿಂದ ಈಗ ಏನಾಗುತ್ತೆ, NH3 ಹೊರಗೆ ಬರುತ್ತೆ. ಏನಾಗುತ್ತೆ, NH3 ಹೊರಗೆ ಬರುತ್ತೆ. ಆ NH3 ಹೊರಗೆ ಬಂದ್ಕೊಳ್ಳಿ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ, ಈ ವೆಲ್ಡು ರಿಂಗ್ ಏನುಂಟಲ್ಲ ಅವು ಮುಚ್ಕೊ ಬಿಡುತ್ತೆ. ಇಲ್ಲಿ ಬರೀತೀನಿ ನೋಡಿ. I'm going to write as what you have got. C double bond O NH2 C double bond O NH2 ಅಲ್ವಾ? ಸೊ ಏನಾಗ್ತಾ ಉಂಟು, ನೀವು ಇದನ್ನ ಹೀಟ್ ಮಾಡ್ರಿ. ಹೀಟ್ ಮಾಡಿದಾಗ ಏನಾಯ್ತು, NH3 ಹೊರಗೆ ಬರ್ತಾ ಉಂಟು ಅಂತ ಹೇಳ್ತಿದೆ. ಅವಾಗ ಏನಾಯ್ತು, ಇಲ್ಲಿಂದ ಈಗ NH2 ಹೊರಗೆ ಬರೋದು ಅಂತ ತಿಳ್ಕೊಳ್ಳೋಣ. ಇದೇನ್ ಮಾಡುತ್ತೆ, 1 H ನ ಹೊರಗೆ ಬಿಟ್ಕೊಡುತ್ತೆ. ಸೊ ಅವಾಗ ಏನಾಗ್ತಾ ಉಂಟು, ಉಳಿದಿರೋದೀಗ ಯಾವುದು, NH ಉಳ್ಕೊಂಡಿದ್ಯಾ, ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಇಲ್ಲಿ ಪಾಸಿಟಿವ್. ಸೊ ಅವಾಗ ಏನ್ ಮಾಡುತ್ತೆ, ಒಂದು ಇಂಟರಾಕ್ಷನ್ ಫಾರ್ಮ್ ಆಗಿ ಎರಡು ಸೆಪರೇಟ್ ಚೇಂಜ್ ಏನಿತ್ತಲ್ವಾ, ಇವೆರಡು ಏನೇ ಓಪನ್ ಉಂಟು, ಇವೆರಡು ಈಗ ಕ್ಲೋಸ್ ಆಗ್ಬಿಡುತ್ತೆ. ಸೊ ದ್ಯಾಟ್ ಇಸ್ ಅ ವೆರಿ ಮಚ್ ಇಂಪಾರ್ಟೆಂಟ್. ಸೊ ನಿಮಗೆ ಫೈನಲ್ ಪ್ರಾಡಕ್ಟ್ ಈ ಒಂದು ಕೇಸ್ ಅಲ್ಲಿ ಈ ತರ ಬರುತ್ತೆ, C double bond O NH C double bond O NH. So this is an important product which is called as phthalimide. Phthalimide. Can you notice the difference? This was called as what? Phthalamide. This was called as phthalamide. Amide. So this is called as what? Imide. I anta barta untu. Okay. Very much important. He can ask you. So remember, this is called as phthalic acid. This is called as what? Phthalic acid. How can you prepare phthalimide from phthalic acid? And the question kuda arise agbodu. I repeat. How can you prepare phthalimide from phthalic acid? The one thing what you have to do, treat your phthalic acid with a 2 moles of ammonia. First you will be getting an ammonium phthalate, which on heating gives you a phthalamide, which on further strong heating, ammonia gets kicked out and you will be getting a close chain structure which will be called as a phthalimide. Very much important reaction. Okay. I hope so it has been clear. So whenever an acid is reacting with a base, it should give you a salt, which on further heating, water molecules gets kicked off. And in the case, if your acid is your carboxylic acid and ammonia is a base, on the strong heating, when the water molecule is kicked off, the final product you are going to get as an amide. But when you are considering for a phthalic acid, the final product on strong heating by the liberation of ammonia, you will be getting what? Phthalimide. You will be getting as phthalimide. So far we have seen the 2 important reactions. One was with the phosphorus halides. The another important reaction was with respect to your ammonia. So the next important reactions we are going to study, which is called as decarboxylation. What it is called as? Decarboxylation. So guys, the next important reaction we are going to study is called as your decarboxylation. So first of all, we have to understand what do you mean by this decarboxylation. Remember, decarboxylation, whenever this word strikes in your organic chemistry, make sure that you have to know that decarboxylation refers to removal of CO2. Okay, removal of CO2. There are different methods, but I would just like to focus as per your syllabus. That is, we are going to remove the CO2 from the sodium salt of your carboxylic acid. How are we going to prepare the sodium salt? Of course, in our previous reaction, we saw that your carboxylic group is an acidic group. We treated with an ammonia, which was a base. So we got what? Ammonium salt. Now, if I want to get sodium salt, what I have to do? So when you are treating your carboxylic acid, first with NaOH, of course, acid and a base will be giving you as what? RCOO minus Na plus. So it is what? Sodium salt of a carboxylic acid. So when such sodium salt of a carboxylic acid is treated further with a, remember, dry soda lime, very much important. What I am saying? Dry soda lime. That means what? Soda lime means we know it's a composition of your sodium hydroxide with calcium oxide. And do remember the ratio will be in 3:1. That is, if you are considering a 3 moles of NaOH, you have to consider now 1 mole of your calcium oxide. So overall this mixture will be called as your soda lime, and of course this will be dry in nature, anhydrous part. So when such sodium salt of a carboxylic acid is treated with your soda lime, that is NaOH plus CaO, and you are going to heat it, the final product is very much important. We are going to get our hydrocarbon with sodium carbonate. So this is very much important. So they can ask you a question. How can you convert a carboxylic acid to a hydrocarbon? Alva. For example, if I am going to choose CH3COOH, yes, and I am going to here as what? Methane. Okay, I want here what? Methane. How can you prepare methane from ethanoic acid? I repeat, how can you prepare methane from ethanoic acid? So, for example, if I am going to write here NaOH, what are you going to get first? CH3COO minus Na plus. Remember, in the presence of your dry soda lime, that is NaOH, CaO on heating, what it is going to give you? Yes, even the CH3 group ಗೆ ಒಂದು H attach ಆಗುತ್ತೆ ಅಲ್ವಾ? CH3H. So this can be written as what? CH4, which means methane. And remaining as usual Na2CO3. So this is called as your decarboxylation. So whenever your sodium salt of a carboxylic acid, ನಿಮ್ಮ syllabus prakara, they are going from in between the reaction. Now I have just given you one more hint that how you are getting this sodium salt of a carboxylic acid. Where whenever you are treating your sodium salt of a carboxylic acid with your dry soda lime, the final product you're going to obtain will be your hydrocarbon. And do remember, overall reaction has to be taken in heating. Heat ಮಾಡಿದಾಗ ಮಾತ್ರ ಆ ಒಂದು CO2 ಹೊರಗಡೆ ಬರುತ್ತೆ. CO2 ಹೊರಗೆ ಬಂದಾಗ ಏನಾಗುತ್ತೆ? ನಿಮಗೆ ನಿಮ್ಮ hydrocarbon ಸಿಗುತ್ತೆ. For example, if I'm going to use my benzoic acid. Okay, benzoic acid treated with your NaOH. So first of all, you'll be getting as what? Sodium salt of a benzoic acid, COO minus Na plus. Treating this one with the NaOH plus CaO on heating. The final product, whatever you're going to get, will be your benzene. Can you see how from benzoic acid we are preparing your benzene using the concept of your decarboxylation? But I want to ask you one simple question over here. What is that, sir? What is the thing you are going to observe over here? ಏನು ನಾವು ಮೇಜರ್ ಆಗಿ ಅಬ್ಸರ್ವ್ ಮಾಡ್ತಿದ್ದೀವಿ? Just pay focus on the number of the carbon atoms with respect to the reactant and that of your final product. If I choose over here, remember it was having what? 2 alva, 2 carbon atoms. That is, it was an ethanoic acid alva. But the final product, whatever the hydrocarbon you are getting, is having only 1 carbon atom. That is, the final product will be having 1 carbon atom less than that of its reactant. So these are the very much important things one has to note, alva. ಸೊ ಈ ಒಂದು ರಿಯಾಕ್ಷನ್ ಮಾಡಿದಾಗ ಡಿಕಾರ್ಬೋಕ್ಸಿಲೇಷನ್ ಮಾಡಿದಾಗ of course we are getting a hydrocarbon, but what is the major tendency we are going to get over here? One carbon atom less than that of your reactant. Is that clear? Why I'm saying this, I'll give you an exercise over here. You just recall the concept of co-base electrolysis. Co-base electrolysis. Okay, product to same, reactant to same. ಅಂದ್ರೆ ಬರೋದು ಹೈಡ್ರೋಕಾರ್ಬನ್ ಆಗಿರುತ್ತೆ, ಬಟ್ ಯು ಜಸ್ಟ್ ಕಂಪೇರ್ ದಿ ನಂಬರ್ ಆಫ್ ದಿ ಕಾರ್ಬನ್ ಆಟಮ್ಸ್ ಇನ್ ದೀಸ್ ರಿಯಾಕ್ಷನ್ಸ್. ಸೊ ಡಿಕಾರ್ಬೋಕ್ಸಿಲೇಷನ್ ಮಾಡಿದಾಗ ಇಲ್ಲಿ ಒನ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಲೆಸ್ ಉಂಟು. ಅದೇ ನೀವು ಈ ಒಂದು ರಿಯಾಕ್ಷನ್ ಕೋಬೇಸ್ ಎಲೆಕ್ಟ್ರೋಲಿಸಿಸ್, ದಟ್ ಇಸ್ ಬೈ ಯುಟಿಲೈಸಿಂಗ್ ಯುವರ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಕರೆಂಟ್, ಇಫ್ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಡೂ ದಿಸ್, ಯು ಜಸ್ಟ್ ಸಿ what is the product you are going to get when you are considering the same ethanoic acid. Okay, this is an assignment for you. Once you watch this video, you can comment me what is the main difference between your co-base electrolysis and that of your decarboxylation. Is that clear? But as per your syllabus, we came to know as what? Whenever your carboxylic acid is undergoing a decarboxylation, okay, but do remember, whenever you have to do the decarboxylation, first you have to convert your acid to a sodium salt. Okay, sodium salt of a carboxylic acid. So in treating that sodium salt with your dry soda lime in the presence of heating, on further heating, you will be getting the final product as your respective hydrocarbon, which will be having one carbon atom less than that of its reactant. Is that clear? Okay. The next important reaction we are going to deal under this topic is called as your halogenation. And under this halogenation, I have to mainly mention an important named reaction which is called as HVZ reaction, which means Hell-Vollard-Zielinski reaction. HVZ reaction ಅಂತ ಕೇಳೋ ಚಾನ್ಸಸ್ ತುಂಬಾನೇ ಇರುತ್ತೆ, because it is a named reaction under this carboxylic acid chapter. Okay, so what is this Hell-Vollard-Zielinski reaction? Remember guys, ಈ ಒಂದು ರಿಯಾಕ್ಷನ್ ಆಗಬೇಕು ಅಂದ್ರೆ ನಿಮಗೆ ಗೊತ್ತಿರಬೇಕು ಏನಂತ, ನಿಮ್ಮ ಕಾರ್ಬೋಕ್ಸಿಲಿಕ್ ಆಸಿಡ್ ಅಲ್ಲಿ ಒಂದು ಆಲ್ಫಾ ಹೈಡ್ರೋಜನ್ ಇರಲೇಬೇಕು. ಐ ರಿಕಾಲ್, ನಿಮ್ಮ ಕಾರ್ಬೋಕ್ಸಿಲಿಕ್ ಆಸಿಡ್ ಗ್ರೂಪ್ ಅಲ್ಲಿ ಒಂದು ಆಲ್ಫಾ ಹೈಡ್ರೋಜನ್ ಇರಲೇಬೇಕು. ಆಲ್ಫಾ ಹೈಡ್ರೋಜನ್ ಅಂದ್ರೆ ಅರ್ಥ ಏನು? ಯಾವ ಕಾರ್ಬನ್ ಆಟಮ್ ಡಬಲ್ ಬಾಂಡೆಡ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಅಡ್ಜಸೆಂಟ್ ಇರುತ್ತೋ ಅದಕ್ಕೆ ನಾವು ಆಲ್ಫಾ ಕಾರ್ಬನ್ ಆಟಮ್ ಅಂತೀವ. ಆ ಆಲ್ಫಾ ಕಾರ್ಬನ್ ಆಟಮ್ ಮೇಲೆ ಯಾವ ಹೈಡ್ರೋಜನ್ ಇರುತ್ತೋ ಅದನ್ನ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ? ಆಲ್ಫಾ ಹೈಡ್ರೋಜನ್ ಆಟಮ್. So whenever this Hell-Vollard-Zielinski reaction has to take place, do remember, I'm repeating it, your carboxylic acid group should have an alpha hydrogen atom. Why is it so? Because whenever a carboxylic acid having an alpha hydrogen atom is going to react with a halogen, that is the reason we are calling it as an halogenation, you are going to get an alpha halo acid. Okay, and these reactions are taking place in the presence of your red phosphorus. Okay, red phosphorus. So confusion, let us write it. For example, if I'm going to take a general reaction, it's a RCH2 COOH, and I'm going to treat this one with a halogen in the presence of, very much important, remember, red phosphorus irlebeku. Red phosphorus irlebeku. Red phosphorus ಏನು ಅಂತ ನಿಮಗೆ ಗೊತ್ತಾಗುತ್ತೆ when we will be dealing with your P block elements. But just for a while, you just remember what? When you are treating your halogen in the presence of a red phosphorus along with the water, what will happen? Here, ಯಾವ ಒಂದು ಈಗ ಇದರಲ್ಲಿ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ಇದೇನಾಗುತ್ತೆ? C double bond ಅಂತ ಬರ್ಕೋಬಹುದಲ್ವಾ ಇದನ್ನ? C double bond OH. So carbon atom which is adjacent to the double bonded carbon is this carbon. So this is alpha. So ಇದಕ್ಕೆ ಇನ್ನೊಂದು H ಉಂಟಲ್ವಾ? So this will be what? Alpha hydrogen. So ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ? ಒಂದು ಹ್ಯಾಲೋಜನ್ ಈ ಹೈಡ್ರೋಜನ್ ಅನ್ನು ತಗೊಂಡು ಇನ್ನೊಂದು ಹ್ಯಾಲೋಜನ್ ಏನು ಬರುತ್ತೆ ಇಲ್ಲಿಗೆ ಬಂದು ಕೂರುತ್ತೆ. ಸೊ ವಿಲ್ ಬಿ ಗೆಟಿಂಗ್ ಆಸ್ ವಾಟ್? RCH X COOH plus HX. So this is called as what? Alpha halo acid. Alpha halo acids. So that is the reason whenever we have to do the halogenation with respect to your HVZ reaction, two important aspects are very much important. What are those? First important thing is your carboxylic acid should have an hydrogen atom. Second most important thing is what? You have to consider the reaction in the presence of your red phosphorus. Then only what happens, that alpha hydrogen will be replaced by another halogen atom giving you an alpha halo acid. For example, if I choose CH3 C double bond OH in the presence of halogen. For example, let us take as a Cl2 itself, Cl2, and here I am using my red phosphorus in the presence of water. So ಏನಾಗುತ್ತೆ ಈಗ ಇಲ್ಲಿ of course ಈಗ ಇದನ್ನ ಈ ತರ ಬರ್ಕೋಬಹುದಲ್ಲ CH2H. So of course now this will be my alpha hydrogen atom. So ಇವಾಗ ಇಲ್ಲಿ ಏನು ಬರಬಹುದು Cl CH2 COOH plus HCl. So this is your chloroacetic acid. Chloroacetic acid. So now I will ask you a question. Can we consider this HVZ reaction to methanoic acid? ಅಲ್ವಾ ಮಾಡಕ್ಕಾಗುತ್ತಾ? ಆಗಲ್ಲ. ಯಾಕಂದ್ರೆ ಡಬಲ್ ಬಾಂಡೆಡ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಪಕ್ಕದಲ್ಲಿ ಯಾವ ಆಲ್ಫಾ ಕಾರ್ಬನ್ ಆಟಮ್ ಇಲ್ಲ. Since it is not having the alpha carbon atom, what happens? It will not be having a alpha hydrogen atom. So this product we cannot get through this methanoic acid. So two important aspects I am repeating once again in a HVZ reaction. What are those? Come on, repeat with me. First and the foremost thing, your carboxylic acid group should have an alpha hydrogen atom, and also the reaction should be carried out in the presence of red phosphorus. So whatever the final product you are going to get will be your alpha halo acid. ಯಾವ ತರ ಬಂತಿದ್ದು, ಯಾವ alpha hydrogen atom ಇತ್ತು ಅದನ್ನ replace ಮಾಡಿರೋದು ಯಾವುದು? ನಿಮ್ಮ respective halogen. Is that clear? Very much important. Okay, it's a named reaction, so you have to remember it and also practice it. Coming to the next important reaction, we'll be going with your nitration. So what do you mean by this nitration? Of course, we know that whenever you're considering your organic compound and going to react with it a nitrating mixture, that is your concentrated sulfuric acid and concentrated HNO3, NO2 plus ana ಒಂದು electrophile ಬರುತ್ತೆ ಅಲ್ವಾ? But the major question arises now, where does this electrophile is going to attach? Alva? So do remember, when I'm saying you that whenever you're treating your carboxylic acid, COOH, treated with respect to your concentrated H2SO4 and a concentrated HNO3, I will be saying that you will be getting a meta-nitrobenzoic acid. What I'm saying, you will be getting as what? Meta-nitrobenzoic acid. If you can just recall, in the previous classes, we were giving you the two important products. One was a para, another was an ortho. But when I'm talking about here with respect to the carboxylic acid, and what I'm saying, you're getting what? Meta position. Question arises, Alva, why is it so? So in order to understand that, you have to see the resonance structure. ಏನಿರುತ್ತೆ resonance structure? So for example, if I'm going to write like this my benzoic acid, of course due to the electronegativity difference between your oxygen and carbon ಏನಾಗುತ್ತೆ ಇಲ್ಲಿಗೆ ಹೋಯ್ತು ಅಂತ ತಿಳ್ಕೊಳ್ಳೋಣ. ಇಲ್ಲಿಗೆ ಹೋದ್ಕೊಳ್ಳಿ ಏನಾಯ್ತು, ಈಗ ಕಾರ್ಬನ್ ಮೇಲಿರೋ ಎಲೆಕ್ಟ್ರಾನ್ ಡೆನ್ಸಿಟಿ ಕಮ್ಮಿ ಬರುತ್ತೆ. ಸೊ ಇಲ್ಲಿಗೆ ಶಿಫ್ಟ್ ಆಯ್ತು. ಇಲ್ಲಿಗೆ ಶಿಫ್ಟ್ ಆದಾಗ ಏನಾಗುತ್ತೆ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇಫ್ ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ರೈಟ್ ಹಿಯರ್, ಯು ವಿಲ್ ಬಿ ಗೆಟಿಂಗ್ ಎಸ್ CO ಮೈನಸ್ ಅಂಡ್ OH. ಸೊ ಇಲ್ಲಿಗ ಹೋಯ್ತು, ಇಲ್ಲಿ ಡಬಲ್ ಬಾಂಡ್ ಫಾರ್ಮ್ ಆಯ್ತು, ಇಲ್ಲಿಗೆ ಏನಾಯ್ತು ಪ್ಲಸ್ ಬಂತು ಅಲ್ವಾ? ಸೊ ಈ ಪ್ಲಸ್ ನ ಸ್ಯಾಟಿಸ್ಫೈ ಮಾಡಕ್ಕೆ ಏನಾಗುತ್ತೆ, ಈ ಬಾಂಡ್ ಈ ಕಡೆ ಜರುಗುತ್ತೆ. ಜರ್ಗದಾಗ ಏನಾಯ್ತು, ಸೊ ನಾವು ಹಿಯರ್ ಯು ವಿಲ್ ಬಿ ಗೆಟಿಂಗ್ ಅ ಡಬಲ್ ಬಾಂಡ್ ಹಿಯರ್. So not over here. Here you will be getting a double bond, C double bond O minus, and here OH, and here you will be having one, and here you are getting a positive. Of course, now what happens, in order to balance this positive, this will come over here. So when it comes over there, what happens? So here you will be getting a positive here, and here you will be having your bond. So double bond CO minus OH. So what are the things you are observing in this resonance structure is that, of course, we know that whenever we are taking a nitrating mixture, you are getting an electrophile. That is your NO2 plus. Of course, when you are seeing the resonance structure, what we are observing in the ortho and the para position, we are having a positive sign. That means what? Incoming is also a positively charged species. Availability of the position in the ortho and the para is also a positive. So what happens? Repulsion takes place. What happens? Repulsion takes place, or like charges repel. So ಆ ಒಂದು ಪೊಸಿಷನ್ ಯಾವ್ದು ಖಾಲಿ ಉಂಟೀಗ ಈಸಿಯಾಗಿ ಬಂದು ಕೂರಕ್ಕೆ your meta position. So that is the reason whenever we are talking about a carboxylic acid treating with a nitrating mixture, we will be getting a meta-nitrobenzoic acid. Very much important concept. Recall it and remember it. Okay? And similarly, when you are coming with respect to now bromination. Remember here, whenever you are doing your bromination of your benzoic acid, product is we are going to get in the meta position itself, but majorly important thing here, we require a halogen carrier catalyst. ಇರಲೇಬೇಕು. ಆಲ್ಕೋಹಾಲ್ಸ್ ಫಿನಾಲ್ಸ್ ಅಲ್ಲಿ ಬ್ಯಾಡ್ದಿತ್ತು ಅಲ್ವಾ, ನಾವು ಅದನ್ನ ನೋಡಿದ್ವಿ. ಬಟ್ ಇಲ್ಲೇನು ಹೇಳ್ತಾ ಇದೀವಿ ನಾವು ಕಾರ್ಬಾಕ್ಸಿಲಿಕ್ ಆಸಿಡ್ ಗ್ರೂಪ್ ಅಲ್ಲಿ ವಿ ಆರ್ ಇನ್ ದಿ ರಿಕ್ವೈರ್ಮೆಂಟ್ ಆಫ್ ಯೋರ್ halogen carrier catalyst, because this group is there, it is a deactivating group. So of course, as we have seen earlier, here also you will be getting now in the meta position, which will be called as a meta bromobenzoic acid. What is the main thing you have to remember? Under the bromination of your carboxylic acids, make sure aldehydes irbodu, ketones irbodu, carboxylic acids irbodu, you are going to get in a meta position itself. Okay, whenever your electrophile is coming, remember electrophile is coming. Okay, illu kuda Br plus barta iradu, not as a Br minus, it's not coming, Br plus anta barta untu. So that is the reason it is acquiring your meta position. So when you are talking about nitration, we are getting a meta nitrobenzoic acid. Coming with respect to the bromination, we are getting as a meta bromobenzoic acid. And one of the important note I have to mention over here, what is that? So far, whenever we are dealing with the reactions in all the organic chemistry chapters, we have seen the Friedel-Crafts reactions. Alva, alkylation irbodu, acylation irbeku. Remember, your carboxylic acid do not undergo those Friedel-Crafts reaction. Very much important. What I am saying, recall once again, repeat with me, your carboxylic acid will not undergo your Friedel-Crafts reaction. It may be alkylation or acylation, no matter. It will not undergo it. The only reason is because due to the deactivating nature of your carboxylic group. ಇಲ್ಲಿವರೆಗೂ ನಾವು ನೋಡ್ತಾ ಬಂದ್ವಿ ಹ್ಯಾಲೋ ಆಲ್ಕೇನ್ಸ್, ಹ್ಯಾಲೋ ಅರಿನ್ಸ್ ಇರ್ಬೋದು, ಆಲ್ಕೋಹಾಲ್ಸ್ ಇರ್ಬೋದು, ಅಥವಾ ನಿಮ್ಮ ಫಿನಾಲ್ಸ್ ಇರ್ಬೋದು, even your aldehydes and ketones ಇರ್ಬೋದು, they were undergoing your Friedel-Crafts reaction. But when you are considering with respect to the carboxylic acid, do remember, due to its deactivating nature, it doesn't have that capacity so that it can interact with the Lewis acid of AlCl3 and form the respective alkyl or an acyl product. So that is the reason we say that your carboxylic acid will not undergo Friedel-Crafts reaction. Is that clear? So these were the important reactions one has to know when we are dealing with the chemical properties of your carboxylic acid. Okay, but there is a one more important reaction. Of course, this is not included in your syllabus, but it is there in your NCERT book. So that is the reason I just want to add it in this video itself, which is called as formation of anhydride. Formation of anhydride. Of course, this is also a reaction which involves the COH bond. Yen heltare andre, whenever a carboxylic acid, when they are treated with, or instead of using the word as treated, I have to say as heating. So whenever you are heating your carboxylic acid with a mineral acids, that could be your sulfuric acid irbodu, athwa ನಿಮ್ಮ P2O5, phosphorus pentaoxide irbodu. So that case may what happens, your carboxylic acid gets converted to your acid anhydride. For example, CH3 C double bond OH plus C double bond OH CH3. Of course, it's an ethanoic acid. So when it is treated with your sulfuric acid, for example, heating, remember what is happening, CH3C double bond O. Remember how I am writing, C double bond O CH3. So this is called as what? Ethanoic anhydride. So many times I have mentioned you anhydride ಯಾವ ತರ ಬರಿತೀವಿ ನಾವು, RCO twice O ಅಂತ ಬರಿತೀವಲ್ವಾ. ಯಾಕೆ ಬರಿತಾ ಇದ್ವಿ, ಇಲ್ಲೇ ನೋಡಬಹುದು ನೀವು, R ಎಷ್ಟುಂಟು, 2 ಉಂಟು. ಇಲ್ಲಿ RCH3 ಅಲ್ವಾ, 2 ಉಂಟು. CO ಎಷ್ಟುಂಟು, 2 ಉಂಟು. ಸೊ ಇದು ಒಂದು CO, ಇದು ಒಂದು CO. ಒಂದು O ನ ಹೊರಗೆ ಬರಿತಾ ಇದ್ವಿ. ಯಾಕೆ? ಬಿಕಾಸ್ ಇಟ್ ಇಸ್ ಆಕ್ಟಿಂಗ್ ಆಸ್ ಅ ಬ್ರಿಡ್ಜಿಂಗ್ between this one molecule, this one molecule. Alva, that is the reason whenever we have to write the general formula of an anhydride, we were writing it as RCO within the bracket twice and outside O. So ಯಾವಾಗ ಬರುತ್ತೆ ಈ ತರ anhydrides? So whenever you are treating your carboxylic acids with a mineral acid. So mineral acids treat ಮಾಡಿದಾಗ ಏನಾಗ್ತಾ ಉಂಟು, of course water molecules ಹೊರಗೆ ಹೋಗ್ತಾ ಉಂಟು, ಅವಾಗ ಏನಾಗುತ್ತೆ, you will be forming your respective anhydrides. Okay, very much important reactions we have seen so far. Coming with respect to the last concept of this topic, which is called as uses. Alva, uses. What are the uses? Ishtella bodmele adodenu use annad bekalva. Of course, the major use, of course, you may be knowing, gobi manchuriga haktivala vinegar, but don't write it. Okay, just for making you understand, I'm saying it. Everybody will be very fond of gobi manchuri. There we will be using your vinegar acid. Of course, it is also containing your acetic acid itself. So that vinegar is not only used for your gobi manchurians, guys. Remember, it is one of the good preserving acid. Okay, it can be used for preserving and also for flavoring the food. Vinegar ಹಾಕಿದಾಗಲೇ ತಾನೆ ಆ ಒಂದು ಟೇಸ್ಟ್ ಸಿಗುತ್ತೆ ನಮಗೆ ಟಂಗ್ ಅಲ್ಲಿ, ಬಿಕಾಸ್ ಇಟ್ ಈಸ್ ಮೇಕಿಂಗ್ ಯೋರ್ ಟೇಸ್ಟ್ ಬಡ್ಸ್ ಟು ಸಮವಾಟ್ ಏನಂತೀವಿ ಚುರುಕುಗೊಳಿಸಕ್ಕೆ ಆ ಒಂದು ವಿನೆಗರ್ ನ ಆಡ್ ಮಾಡ್ತಾರೆ, ಫ್ಲೇವರಿಂಗ್ ಏಜೆಂಟ್ ಆಗಿ ಆಡ್ ಮಾಡ್ತಾರೆ. ಕಮಿಂಗ್ ಟು ಅದರ್ ಯೂಸಸ್, ಯೋರ್ ಮೆಥನೋಯಿಕ್ ಆಸಿಡ್ ಕ್ಯಾನ್ ಬಿ ಯೂಸ್ ಆಸ್ ಟು ಕೋಆಗುಲೇಟ್ ಯುವರ್ ರಬ್ಬರ್ ಲ್ಯಾಟೆಕ್ಸ್. ಕೋಆಗುಲೇಟ್ ಅಂದ್ರೆ ಗೊತ್ತಲ್ವಾ, ಡಿಸ್ಪರ್ಸ್ಡ್ ಆಗಿದ್ನ ಒಗ್ಗೂಡ್ಸಕ್ ಕೂಡ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಟೆಕ್ಸ್ಟೈಲ್ ಇಂಡಸ್ಟ್ರಿಯಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತೀವಿ, ಡೈಯಿಂಗ್ ಅಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತೀವಿ. Even your sodium benzoate is also used as a food preservative. Coming with respect to your higher fatty acids, okay, a soap manufacture of the soaps ನೋಡಿ ಯಾವ ತರ ನಾವು ಮ್ಯಾನುಫ್ಯಾಕ್ಚರ್ ಮಾಡಿದೀವಿ ಸರ್ಫೇಸ್ ಕೆಮಿಸ್ಟ್ರಿಲಿ, ಅಲ್ಲಿ ನೋಡಿದಾಗ ಗೊತ್ತಾಗುತ್ತೆ. There we have used a higher fatty acid for the manufacture of your soaps and detergents. So these are the general uses of our respective carboxylic acids. So this was the last concept we have to cover under the topic of your carboxylic acid. We came to know the physical properties and also the chemical properties. And in the chemical properties, so far we have studied that how does your carboxylic acid reacts with your phosphorus halides and how does it is going to give you acyl chlorides. Coming with respect to that of your ammonia, how it is going to give you amides. Yeah, how does your phthalic acid can be converted to phthalimide? Yes, by the strong heating, by the evolution of NH3. Then we came to know with respect to Hell-Vollard-Zelinsky reaction. Yeah, and whenever we are carrying out this Hell-Vollard-Zelinsky reaction, two important aspects we came to know. What are those? First, the important thing, the carboxylic acid should contain an alpha hydrogen atom. Secondly, the reaction has to be carried out in the presence of red phosphorus. Mentioning red phosphorus because in P block, when you are coming with the coming to that topic, you'll come to know there is also existing a black phosphorus, white phosphorus. So that is the reason we are very much particular about the color of the phosphorus. That is your red phosphorus itself. Okay. So then we came to know with respect to decarboxylation, removal of CO2 from an sodium salt of a carboxylic acid to give you the hydrocarbon. There I have given you an assignment. Compare the preparation of your hydrocarbon, one with respect to decarboxylation, another with respect to co-base electrolysis. Take the reactant as your ethanoic acid. Give me the final product as your comment in this video as soon as you see this video. Then we came to know with respect to the nitration and the bromination, and we came to know that both the part is going to attack in the meta position because of the deactivating nature of your carboxylic group. Then we came to know one NCERT textbook one point, that is with respect to the reaction of the carboxylic acid with respect to mineral acid to give your anhydrides. Alva. So these are the important concepts so far we have covered. So this was the last video of the carboxylic acid. Okay. So in the next chapter, we are going to see with respect to the amides. Okay, completely different chapter it would be because till now whatever we have seen with respect to the carbon and the hydrogen. So in our next organic chapter, we are going to see with respect to the nitrogen and hydrogen. Okay. Of course, the concept we are going to derive from the respective what we have dealt so far. So now for a while you just have a revision whatever we have dealt and study well. Okay. So this completes your chapter of aldehydes, ketones and carboxylic acids. Is there any doubt? You can just comment me in the comment section or you can just post your doubts in my WhatsApp group.